Hi to today's stream. We will once again, tackle the latest Advent of Code challenge. Today is day 20. Again, we will be using Go. And again, the first and foremost goal is to get both stars. So far, I've been pretty bad at having time after we got to 2 stars, so we'll see what happens today. But if we do have the time, I will try to refactor the code into something that I would be more comfortable actually like deploying, actually handing in at work or whatever. But we'll see how it goes. Today I have a pretty hard cutoff at 9 p.m. because I have other plans. So we have exactly 2 hours pretty much. So we'll see how far we get. So let's dive in. Day 20, Jurassic Jigsaw. The high-speed train leaves the forest and quickly carries you south. You can even see a desert in the distance. Since you have some spare time, you might as well see if there was anything interesting in the image. The Mythical Information Bureau satellite captured. After decoding the satellite messages, you discover that the data actually contains many small images created by the satellite's camera array. The camera array consists of many cameras rather than produce a single square image. It produces many smaller square image tiles that need to be reassembled back into a single image. Each camera in the camera array returns a single monochrome image tile with a random unique ID number. The tiles, your puzzle input, arrived in a random order. Okay, that's fine. Worse yet, the camera array appears to be malfunctioning. Each image tile has been rotated and flipped to a random orientation. Oh no. Your first task is to reassemble the original image by orienting the tiles so they fit together. To show how the tiles should be reassembled, each tile's image data includes a border that should line up exactly with its adjacent tiles. All tiles have this border, and the border lines up exactly when the tiles are both oriented correctly. Tiles at the edge of the image also have this border, but the outermost edges won't line up with any other tiles. For example, suppose you have the following 9 tiles. Okay, I don't understand yet. By rotating, flipping, and rearranging them, you can find a square arrangement that causes all adjacent borders to line up. Okay, so it's literally just like find one border that is the same as some other image. Or are they? No, they are not the same. Okay. To check that you've assembled the image correctly, multiply the IDs of the 4 corner tiles together. If you do this with the assembled tiles from the examples above, you get this. Assemble the IDs. Now the question I have is, so apparently like each of these has one border in common with one other tile. The question is that unique, or is it possible to have more than one border? But I guess we will find that out as we go along. Let's first download the input. And then let's see how we get on. 2020, day 20. And here the same. And as always, we start with boilerplate, package main, func, read input. And the input will be a slice of tiles. And each tile will have an index. And how do we do this? A slice of string, let's say, for the tile data. And we will return a slice of tile and an error. So we will just use a slice of string, so every string is one row in the image, and we will just hope that all the rows have the same width, or rather we will check that. Again, we go line-wise through the input. Oops. And there are basically 2 cases. I will just open the input so that we can see how the input looks. One is we see there are three cases. One is we see a tile line, or we see an empty line, or we see like the data. And we will start expecting a tile and then read tile data until we find a new line. And once we got the empty line, we go back to expecting a tile. So let's just say the current tile is a string, or is a tile actually. And do we have a tile 0? No, we don't have a tile 0, so we can just assume index 0 means the tile is empty. If the current tile's index is 0, that means basically, like, this is what we will use as a signal to say we are expecting a tile ID. If scan tile D into current dot index, then if there's an error, we will return that error for now, and continue. And then we are in tile data state. So if the current index is not 0, this means we have read a tile index and we are reading tile data. So we will just we should probably also add the text to actually scan from to here. So if s.text if L is the empty string, this means we are in an empty line. This is our signifier that we've reached the end of tile data. We will just append the current tile and set the current tile to an empty tile again. Otherwise, we say current dot tile equals append current dot tile the line. So and like, yeah, I think this should be fine. Like, this should be fine as long as all the tiles have the same dimension and dimensions and everything is like in order. So if checking for errors, not text. And now let's just for safety go through all our tiles and check that they actually have the same dimension. I'm also wondering, yeah, there's an empty line at the end of the input, so that's also fine. But we can also do a if current dot tile. Let's just assume there's an empty line at the end, and this will bite me in the ass at some point. For all tiles, if the length of t.tile is not the same, so if we don't have any tiles, we should check that. If the length of tiles, this is the number of rows in the current tile. If that is not the same as the number of rows in the first tile, tiles have different number of rows, and if that's not the case, we check if if len t.tile if len, we should also check that the first tile that the tiles aren't empty, is 0. Lots of validation. tiles are empty, and if the length of t dot tile 0 is for row in t dot tile, if the length of the row is not the same as the length of the first row, return nil errors.new. Tiles have different number of columns, and this just checks that the tile has the same number of columns throughout. We actually want to check that it has the same number of columns, like that all tiles have the same number of columns. So oh, let's also do all len tiles 0 dot tile 0 equals 0. So this will check if the first tile has no rows, and this will check if it has no columns, and then we check each tile for internal consistency. But instead of doing this here, we will check tiles 0 dot tile 0. So we will check it against the first row in the first tile, and that way we basically return an error if any of the tiles have, like if not all of the tiles have the same number of rows and columns, we return an error. And this should theoretically work if len tiles is obviously broken. Yes. So let's first see if we can do this. So does this build? Yes. Does it return any error? log.fatal r. Yeah, so, oh, I also forgot once again to tweet out that this is actually happening. Happening now. Okay, yes, okay, where were we? We wanted to check whether we can actually read the input. Tiles have different numbers of rows. That is not great. So, tile, and we will just use an index. Tile %d has different numbers of rows, and this will be the index of the current tile. Encode to errors.new. This will be .errorf. Tile 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it doesn't actually have a different number of rows, so there's something wrong. Something wrong with this. Something wrong with our code. Oh, this should be, of course, a continue. Now it works and doesn't throw an error. So it seems we have hopes that we can actually read our input correctly. Now to the actual problems. So what we need to do is we need to find for every edge, for every tile, we need to find another tile with that has one edge in common. And so I think the way we will do this is we will use a hash map, where in the hash map we will share a store for each possible edge, like a string with the edge in order, the index of the tile with that edge, and maybe even the rotation. And so let's try to do that. Yeah, for now, let's not call it. Let's just start. Func reorder tiles. Tiles. And we might return an error if we can't do it. So, one question, how many tiles are there? Multiply the IDs of the 4 corner tiles. Grab there are 144 tiles, so it will be a 12 by 12 square, I assume. Can we assume that it's square? Square image tiles. Yup. Okay, so it's supposed to be a square, so it will be like 12 square. A 12 by 12 thing. Okay, so type edge is a struct, and then we will have edges will be a map from string to edge, and an edge has a tile index and it has a edge index where, let's say, like 0 will be the upper edge, 1 will be the right edge, 2 will be the lower edge, and 3 will be the left edge, or something like that. We will see. So for every tile, we say edges. So the first edge will be just the first row. Is an edge, and the edge has... Oh, one thing we actually should do is we should say... because we will have more than one edge per... Like there will be more than one instance for many edges, so for most edges, and maybe even for all, we will see. So the first edge will be... tile 0, comma, edge. So we'll have as a tile ID, it will have the index of the tile, and as the edge ID, it will have 0. So this is the first edge we have. Then we also get an edge that is the last row of the tile. Man, this is let me make it easier by saying first let's just store the string also, and then we don't have to we can just collect them for now without having to repeat ourselves so often with like all the indices and stuff. Edge. And here the str will be t.tile0. Here the str will be t.tile the last row. The tile will still be I, and the edge will be 2 in this case. And now the left and the right tile we actually have to assemble manually. Because they are not just one string. We have to go through all the rows. So we say var e0 or e1, e3 are bytes, and then we say for I equals 0, I less than len t.tile, I plus plus. We should use a different... Oh no, it doesn't matter for now. We should just for clarity use a different index here. And the first edge will be the right one, so we say e1 equals append e1 t.tile j len t.tile j minus 1. And e3 will append the first byte in this tile. And now these are byte slices of the correct representation. So we say es equals append es edge str is t.tile is not tile tile, but it's a string of e1. The tile will be I, and the edge will be 1, and the same for e3. And now we should have all our edges hierarchy. Yeah, we will see. We will see. Nice to see you again, for the record. Yeah, so far, like from what I've seen, at least the first half seems doable. But I mean, we will see. We all know what happened yesterday, so we will see. We will see. Let's append all the edges to our map. E.str.e. Okay, so now edges should be a map that contains for every edge, for every string representation of an edge, all the tiles, like all the edges with tile and edge ID that have that string. And for now, what I will do, instead of actually trying to solve the problem generally, we will just check for a second whether there are edges that appear more than twice. If every edge appears at most twice, then we know that there is like a unique simple mapping. Otherwise, we know that there isn't. So let's check that and say for all edges, if the length of E, so E is actually pluralized because it's a slice of edge, is larger than 2, then we say return .error_f edge %q appears more than twice. Yes. Okay. The key. And what we will also do is we will count how many edges appear exactly once, and that should be like if the problem is ideally easily solvable, that should be 12 plus 12 plus 12 plus 12, so 48. So this is just like, this code will not appear in the final solution. This is just for me to see if the problem is simply structured. If len es equals 1, we will say n++ and say if n is not 48, we will return .error_f more than 48 edges, tiles edges are not unique, or more or less. More or less, and otherwise nothing. And this is just, again, this is just for me to see if we can, if the problem is easy. And some compilation errors. Oh, I will also just this is this 77. This should be mate. Okay, Vim is apparently embarrassingly hard to use for me. Cannot use one as type string. Why are you trying to use one as type string? Wait, this is something that oops, I need to test this for a second, sorry. This is unrelated to anything. Just the compiler error confused me. Fun. I should probably report that because, like, obviously, like, you can't subtract strings, so I should keep that in mind as a fun little Go pop quiz. The compiler message should be more. I should actually just say. Just to make sure. 342 edges are unique. Well, fudge. Oh! Of course, because like we rotate these. Okay, so we rotate the tiles. So we actually have to, if we, for example, if we look at the bottom tile, we have to reverse it because if we rotate it by 180 degrees, it will be reversed. And also, can they be flipped? Each image rotated and flipped. So they can be both rotated and flipped. Cool. So we need to actually, with every edge, also include its flipped thing. Wow. Okay. Flipped, false. Flipped, true. So the bottom edge will be flipped by default. E1 is this edge. Yeah, this is actually in the right orientation because we are going top to bottom. So this is flipped false. And this should be considered flipped. And then we also need to add the flipped version. And the string for that needs to be reversed. So there is no string reversal function for good reason, but anyway, reverse as string string. Len s I++, write byte si, and this should of course be the other way around. And so e.str is equal to reverse e.str. So now we append each edge, and we also append the flipped version of each edge with the reversed key. And let's see if that builds and does things. 96 edges are unique. So that's. Oh yeah, because now this is correct, because now we have with each edge also its flipped representation in the map. So we would actually expect twice the number of flipped edges in the map. So with this should actually, so if I now understood everything correctly, we have now transformed our problem, at least with this set of input data, into one that is somewhat easy to solve for us, because like we have all the edges in their string representation, and we know for each of them whether they are unique or not, and all of that. Do we know actually? Oh, we multiply them together, so it doesn't even matter how the image is rotated or flipped in the end result for what we want. So let's actually try that. One thing I would like to do is, actually this doesn't seem, the first part doesn't seem so hard. One thing that I would like to do is to factor all of this out into its own function. T-tile an edge index with the idea that the lookups and stuff will be easier. And so let's copy all of this. And instead of doing all of this, we say switch E, case 0. Oh, we also need to know whether the thing should be flipped. And this should just return an edge. Oh, in that case, we need to actually export edge. That's fine, let's do that. We don't, because all of this is information that the caller already has. So we don't, we will just return the string representation of that. If flipped, return reverse of t.tile 0, else return t.tile 0. We don't actually need the else branch in this case. Case 1. Actually, let's copy this back up, just because this is actually doing significantly different things. This belongs here, I think. Why doesn't it format? Syntax error 148. Okay. Does it now format? Still doesn't format. Does it now format? Yeah, now it actually formats. Okay. Case 2 is the other easy task. If not flipped, return. Actually, we say if t.tile and t.tile -1, else return reverse of this. And let me copy this. And say first this, and this gets copied into the next case, into the last case. And now if flipped, return reverse string B, return string B. Exactly the same logic as before, just a bit mangled. I'm not quite sure whether this is actually worth doing right now, but whatever. And we need to copy all of this again. And say if flipped, return string B, otherwise return reverse string B. Okay, so this should now return the right stuff for all of them. I don't know, we will see. We will hope. We will hope, we will hope. So one edge, that is first edge is string is extract tile of t, extract edge 0, not flipped. Will have as a tile index I, will have as an edge 0, and will have as flipped false. And then we will do the same for 1 and for 2. Yes, this could be solved more elegantly with a loop, but in for a penny, in for a pound. And then we will do exactly the same as before. And let's hope that this actually works. Missing return. Default, panic, invalid edge index. E. Okay, it still builds, it still does not return an error, so we will just assume for now we have done everything right, even though I assume that I didn't, but that's fine. Okay, so, but this should now mean this thing becomes significantly easier. Why? Well, because now we can look for a unique edge, and once we found a unique edge, we are looking for a tile that has 2 unique edges, and we know that that will be 1 corner, and so we can just use that corner as the top left corner, and then look up its right edge and find the corresponding tile and put that in the correct position, and so on and so on and so on. Hopefully. Of course, the tile index here will be I. Now we actually have to do some reorganization, because once we, I think this is gonna go fine. I hope this is gonna go fine. So we are looking for a tile that has 2 unique edges. We will just do a dumb solution. Var corner tile, and say for all tiles, not range tiles but range t's. Yes. If for all edge indices, and they need to be in the same orientation, but it doesn't matter whether whether that orientation is flipped or not. But we need the edges to be in the same orientation. And I guess we can just look for 2 that are not flipped. E less than 4, E plus plus. Extract edge of the tile, the edge number, one that is not flipped, and say if the length in edges is of this key is 1, then that's 1 unique edge, and then we are looking for a second one. So let's say var unique edges, okay, wait, what am I doing here? Unique edges is an edge. Yeah, this should be a string. That's fine. We can look them up later. So if len ue equals 2, then corner will be just the current tile, and we will break because we have found our tile. Cool. So hopefully this should give us a good corner tile. Ideally, we would also want to rotate it such that the edges are correct. So let's say, oh my god, this is a bit, rotate tile, and we will say which edge is supposed to be the top edge, and this will be we will not need to use flipping right now, and this will return a new tile. Okay, so return a new tile. This tile should just have all the things rotated. So if E is 0, we don't even have to worry about it. Return T. If E is true, this means we need to rotate it 180 degrees. We can just say we can say for I is 0, I less than length T dot tile over 2. So we will just flip every row with the corresponding row from the bottom reversed, and that is the same as rotating at 180 degrees. So we basically we flip it once horizontally and once vertically, and that is the same as rotating 180 degrees. So T dot tile I, T dot tile N, T dot tile minus 1 minus I is equal to reverse T dot tile len T dot tile minus 1 minus I reverse T dot tile I. Right? Yeah, I think this is fine. And then we return T. Does tile have any information apart from that? No. Okay, so and now the more complicated things. Now we need to rotate 180 degrees. Now we need to rotate 90 degrees. And I guess 90 or 270 degrees. The way I think we will do this is first rotate at 90 degrees, implement rotating 90 degrees, and then implementing 270 degrees as first rotating 90 degrees and then rotating another 180 degrees to reuse the code we already have. This is horribly inefficient, but hopefully fine. Var out will be a new tile. And then we will say O dot index is T dot index, and then and then we say for I equals 0, I less than len. So what do we need to do? We need to, every row will be the corresponding slice, the ith column in each line. So we go through we will first go through the rows, through the number of rows, and we will say, then we will assemble the edge, the new row, by saying len T dot tile 0, and say R is append R T dot tile I, so the jth row, the ith column. Yes, I think this is right. O dot tile equals append O dot tile string R. And now O will be a 90-degree rotated tile, so this will have, wait, is this correct? No, this is not correct. Because we had like a a thing that looked like, I will use a small thing, 4, 5, 6, 7, 8, 9. And what we now did was we said the first element will be, the first row will be 1, 4, 7, the second will be 2, 5, 8, and the third will be 7, 8, 9. Right? That is not actually what we want, because what we actually want is, let me just append that at the end here. What we actually want is we want to rotate it to 3, 6, 9, 2, 5, 8, 1, 4, 7. Like we want to rotate it this way, like counterclockwise, by 90 degrees. So this is garbage. This is not what we want. What we actually want is we want to go we want to go reverse through the row. This is not great code. R equals append r dot tile, right? Because now we go. So the first row will be. We take for each. Wait, what am I doing? This is not what I want. I mean, all of these numbers are the same, but the number of rows in the rows on the output will be the number of columns in the input. And then this should just go through the number of rows, through the rows in reverse. So we take the jth row and the ith column. Is this correct? So this will start with 0, n, which will be, let me just remove what we have here. This will start with the nth, the jth row, which will be the bottommost row. This is not what we want. I'm confused. This is confusing. This is confusing as frick. Let me think about if I can express this more easily. So the first row will consist of the last element of each row. So we will go, I will be the column index. We will use j for the column index. The number of columns. While it's greater than 0, decrease it. J will be the row index. So we will start so we will go once through all the columns, because we will have one row for each column. And now we will go through the rows, and we will go from top to bottom, because the first element in each row will be the last last column of the same row. Wait. Oh God, I'm embarrassed that this is so difficult for me to figure out. I less than len o dot tile I plus plus. Append b o dot tile I j. So is this now correct? O dot tile equals append o dot tile string b. This is the claim that this now does what we want. So we start with j at 2 and with I at 0. So the first element will be row 2, column, no, the column will be 2 and the row will start at 0 because I is the column index, j is the row index. J is the column index, I is the row index. Okay, so a column will be the last column of the first row. Yes, the last column of the first row is 3. This is correct. Then the next will be, we increase I, so we take the first row, like row 1, column 2, which is 6, and then we take row 2, column 2, which is the 9. Then we are done with this loop. This is correct. Then we decrease the column index by 1. And so we first take row 0, column 1, which is 2. And then we take row 1, column 1. Yeah, so I think this is not correct. So this is rotating it by 90 degrees. So if the edge is 1, this is what we want to return. If the edge is 3, we would have to turn it again by 180 degrees from this point on. And the way we will do that is we will just return rotate tile, our output tile by 180 degrees. This is not good code, and I feel compelled to test it. So first, does it compile? Undefined ES 127. Corner declared but not used. Yeah, that's fine. Cool. So let's write a quick test. Oops. Test rotate tile. So, in case you have never never wrote tests for Go, this is a learning opportunity. This is what's called table-driven tests. So what we do is we just create a list of test cases, and then we write some code that runs each test case and checks if it fails. And we will just define our test case as an input tile and a tile that an output that we want. And we will actually, because we don't care about the index, we will just use strings for now. And we will just start with a very simple, with basically the same thing we just had as a test case 456 789, because this should already tell us basically everything we want. And what we want is 369, and then as a second row 258, and then as a second row, we also should say the edge index. And this is the one I'm actually not sure about. 369 147. Is this correct? The edge in this case will be 1. And I guess we will just write four test cases. So 0 should not touch the tile at all. Rotating by 1 should create this result, 369, 258, 147. Yep. Rotating by 180 degrees should reverse the order of the rows and should flip each row. And and mapping to the third tile should flip this around. So this should be 741, 852, 369. Nope, 963. Great. And now we will just, for each test case, throw it at our function and see what happens. we should actually make a deep copy of our tile. Does reflect have a deep copy? That would be nice. Copy. Copies the contents. I don't think this is what we want. It does not have a deep copy, so let's write a copy function or method. Which will return a new tile with the same index. And the tile will be append to the nil slice all the elements of T. Okay, so input is no, okay. T is a tile with the index 42 and the tile is tc.input and the copy is rotate tile. So I want to create a copy so that we can, like, if the test fails, we can output what we actually put in, because the rotate tile function actually modifies tile. Actually, it just shouldn't modify tile, to be honest. I mean, we do this, right? Like, we return a new tile, so we should actually just return a new tile. I think it's fine to return a tile in this case, but in this case, let's say let's just do this. So o.tile equals append o.tile all the tiles of all the strings of T, and then return that, which makes a copy. Let's say o.tile equals make slice of tile of length t.tile, and now we will just do, instead of swapping them around, we will say o.tile I is reverse t.tile this, and then return O, and this already does a copy, so this is already fine. Okay, so now we hope that it doesn't modify the input. Okay, rotate tile in. And now we want to compare. If not reflect, oops, dot deep equal got tc.want. This also needs to be a tile. Want t.errorf rotate tile %q equals %q 1%q. And what we put in is tc.in. What we got will be got.tile, and what we want is tc.want. So we will not care about the index for now. Even though, of course, if the index now doesn't match. This actually needs also the tc.edge, of course. Mutated index to don't care. Rotate tile tc.in and tc.edge. And this should also include the edge. So, does this work? Nope. Does this work? Nope. Where? 192. Order tile make string. 198. Oh, redeclared. Yep. Indeed. This doesn't need this. tc.in, so this is now errors in my test. tc.in undefined, because it's called input. Cool. It panics. Oops. So where does it panic? Rotate tile in 198. Order tile, well, yeah. Better? It passes! Okay, so we have written a test for our rotation function and are now somewhat more confident that it actually does what it's supposed to do, at least on... Oh. Well, this is a great autofocus feature of my camera. Okay. At least on 3x3 tiles. Okay, so I guess extract edge, reverse stuff, corner. We now have a corner. Now we have to figure out how to rotate the corner. Let's say, how do we do this? E0, E1 ins. We need to save like what edges are the actual unique edges, and we will just say E0, E1 equals 0, 0. Or -1, -1, then we don't even need this one. Oh no, let's still do that. We append the edge index, and we will just say here a UE int, so we don't need to redeclare it. And I think this is fine. Corner equals t and break. Yeah, so we go through all the tiles, we reset the unique edges to an empty slice. We go through all edges, re-extract it, see that it's a unique edge, meaning that it only appears once in the entire map. And if so, we append the edge index, and if it's 2, then we are done. So now the next thing we actually need is those 2 edges need to be consecutive. And we will just assume that they are for now. Consecutive modulo 4, of course. So if UE 0 plus 1 mod 4 is unequal UE1 or and UE0 minus or unequal UE1 plus 1 mod 4 return fim.error_f edges %d and %d are not adjacent. UE0, UE1. Just for safety's sake, we will check. We will be paranoid about this. So like this just so the indices are numbered in the edges are numbered in clockwise orientation. So we have like 0, 1, 2, 3. And so 3 and 0 are considered equivalent, adjacent. So if one of them is 3 and the other is 0, that's also fine. Otherwise, they must differ by exactly 1. And this checks both cases. Right, and now we just need to figure out which of these should be edge 0. And that is, like, which of these should be the upper edge. And then we have the orientation of our first corner. And that it will be the smaller one. Let's actually do it this way. Bar E0 int. Case. So this is one case. This is the other case. And the default case will be that none of them is the case. In this case, we will return an error. So in this case, the UE0 is the RPAC, is the higher of the two. No, in this case, UE0 is the lower of the two. So UE0 plus 1 is UE1. So we will say edge 0 should be UE0. And in this case, it's UE1. So we say E0 should be UE1. And now we will rotate our corner so that E0 is up. Right? Okay. All of this just to figure out which is the correct orientation for this corner. But this should actually be what we want. Now we need to reorder our tiles. But now reordering our tiles should be relatively straightforward because we can now just look at the right edge of the last tile we looked at. And then find that edge in our map, look up the correct tile, rotate it to the correct orientation and append it at that position. And then once we have done the entire row, we can continue with the lower edge of the first tile of the last row we looked at, hopefully. So let's see, var out tile or ordered is a tile that contains only the corner. And I think I will now just hardcode 12 as the number of tiles because I'm honestly a bit too annoyed to do it cleanly. So let's see, for len ordered less than len tiles. So until we have everything ordered. So we are looking at if len ordered mod 12. So 12 is how many tiles we have per row. If that is not 0, this is the first case we will care about. This means we are still in the middle of the row. We will extract edge of the last tile we looked at, and we will extract the right edge and say it shouldn't be flipped. And then we will look up this in the map of edges. I'm honestly like, I don't know. Obviously, I'm not in my best at my best today. I think I'm not sure this code will actually do what we want and build and be correct. I think like right now it looks far too complicated to actually work. But yeah, we will see. So this should be the next edge we need. And one of them should be the tile we have. Okay, so we say last is ordered order -1. If e dot, so now we have like this should be have length 2. If length es, let's say, I don't know, is not 2, return from dot error f can't find unique match for edge %q or whatever, or for, yeah. And now one of the edges should have the same index as our last tile and one of them shouldn't. So if es0 dot tile equals last dot index, else if es1 dot tile equals last dot index, else, oops, I'm trying to be as paranoid as possible just so like the complexity of the code at least means we hopefully double and triple check our assumptions. If es.tile0 equals last.index, then we want to take tile 1 and rotate it, say ordered equals append ordered. Then the next tile will be the tile that the es1 belongs to, because es0 we have already appended. So tiles es1 dot tile, and the rotation will be so what we want is that the edge that we found should be at the left, right? And our rotation function, we tell our rotation function which should be at the top. So we actually need to add 3 to that modulo 4, right? No, we should add. So if the edge that we found is 0, we want it to be 3. Yeah, we should add 3 to that and mod 4. This is unreadable, not understandable code. I apologize. I regret my life choices right now. Is that correct? So if the edge is originally edge 0, oh, we should also check whether it's flipped, actually. Okay, the tile we want to append is ts es1.tile. So now we may need to flip it, and we may need to reverse it. We actually should also have a flip function, I guess. Func flip tile t tile. But oh no, now it actually depends on whether we flip first or rotate first. Oh, you know, this is getting far too complicated. Okay, let me try to explain why I'm currently ripping out my hair. So we store whether the edge is flipped or not, but what we don't consider is that if we want the original tile, right? So what we actually want to know, what we actually want to store is, if this is the edge we are looking for, how do we need to rotate the original tile? Like, how do we need to transform the original tile? And the original tile might be flipped and it might be rotated. But it depends, like the outcome will be different whether or not we flip first or whether or not we rotate first. So it's not entirely clear that we actually have the right information here, right? Because the edge index tells us what edge this originally was, but the flip just says whether the edge was flipped or not. It doesn't tell us whether we would need to like flip the tile before or after the rotation, which will create different results, which is honestly super annoying. And I am very, very, very tempted to just throw everything away, table flip, and do like a start afresh, because this approach is starting to get far too complicated. Let me try to think for a second whether I can make this more easy. Yeah, we can make things a little bit easier on ourselves, right? So this extracts the edge. We now have a rotation function, and we will soon have a flip function. So instead of doing something to the edge, we will just always take the upper edge and then we rotate it by the number of steps, right? Like we rotate it in every step, and then we do that 4 times, and then we flip the tile, and then we again rotate it 4 times and store all the edges. And so we will just define that the flipping happens first, and we will change this to like just say the edge will be a number of rotations. Okay, I think I know what I want to do. I will say this will be the number of rotations that we need to do. This will be the tile index, and this will be whether or not we flipped it beforehand. This will be deleted. And instead we will say for each tile we will first rotate it 4 times. J equal less than 4. So we will first take the upper edge. So we will say we will add the edges. Will be the key is t dot tiles I 0, the first row. This is still going to be our edge, but we will now always take the topmost row as a key. Edges, this will be appended to edges t dot tile 0, and the edge will be in this case the string. I'm not sure whether we actually need the string. Do I use it anywhere? No, let's just take it out again for now. So the tile will again be I. The rotation will now be J. This is the number of times we rotated that. And flipped will be, let's not do that. Let's not make it more complicated. Flip will be false for now. Okay, so now we, and every time we did that, we say t equals rotate tile t by 1, right? Yep. So the rotate function is still the same. Now we actually just while we insert the things, we will just after, like, we will take the first row as the key, then we will rotate the tile by 90 degrees, take the first row as the key, rotate by 90 degrees, and we will record how often we have rotated. Then we will flip it, and we will just define flipping as doing one well-defined flip operation. Like maybe it will flip the rows, maybe it will flip the tiles, maybe it will flip the columns. For now, we just don't care. We just say we just focus on one flip operation, and then we will do the same again. But this time we will record that we flipped our function, our thing first, right? And so now we should end up with the same result, but now we actually have recorded, like we have a well-defined record of, well, we flipped first, then we rotated this many times, and this means we can reverse that by first rotating it again the opposite number of times, and then flipping it if we originally flipped it. And so this now actually gives us a thing that we know how to reserve. Like all these checks should still be exactly the same. This will for now also be the same, even though I'm not super happy with that either. But this will now hopefully be simpler. Let's remove this. Great. Yeah, let's remove this. And say, wait, how do we do this? E0 should actually be a full edge, probably. Okay, now, wait, let's also fix this. This is also not good. So how do we do this? We are looking for two edges with the same, two unique edges with the same tile. And we will, I think this code will mostly probably be the same. Let's first implement flip tile, just to be sure what we have. Func flip tile, t tile here, there will be no other parameter. O is a tile. We will do exactly the same thing. We will just do a copy and we will not care about performance. I really hope I will get done today. I'm not convinced. And we will say o.tile equals make len string len t.tile for I equals 0, I less than len t.tile, I plus plus, o.tile I equals t.tile, len t.tile. So we will just flip rows. Minus I. Return O. And I'm sufficiently convinced that this works. So we can just quickly write the test. But we only need one test case in this case. So if we import this tile, the flipped version should have 7, 8, 9, 4, 5, 6, 1, 2, 3, and all of this should be the same, just that this will be flip, 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 and there will be no edge. Passes, yay, okay. This is how quickly you can write a test if you really want to. Okay, so how can we make this more efficient? Can we... What's the easiest way to find corners? Well, finding unique edges should be easy, but then finding out if the tile has more like one or more than one unique edge is a bit more complicated. Let's see. Okay. Yeah, we will range over all edges if the length of the number of edges is 1. This means this is a, like, if it's more than 1, we don't care about it. And now we say var unique edges will be slice of edge, append UEE, and then we can, like, once we have that, we just need to, what did I do? I accidentally UE, yeah. I sometimes get lost. Okay, now we have a list of all the edges that only appear exactly once, and now we need to find 2 that have the same tile with the same flippedness. I mean, technically, yeah, but I don't think this happens. We would know if this happens. Let's just sort the slice by the table they are. The tile they are referring to, and then say return UEI dot tile less than UEJ dot tile, and then we can just say for I equals 1, I less than UE, I plus plus. If UE I minus 1 dot tile equals UEI dot tile, then we have found our corner. Corner tile, or let's say var yeah, let's just reuse UE, because why not? UE equals UE I minus 1 to I plus 1. Break. If len UE is not 2, return dot error could not find corner. So this works. So we are basically, like, we are sorting by the tile the unique edges refer to, and if we can find 2 consecutive one, like, and at that point, like, if one tile is used by 2 edges, they must be consecutive in this sorted array, sorted slice. So we can just find them by this operation. Now we can also say, just to check that I'm correct, if they have different flippedness, UE0.flipped is not UE1.flipped, we have a problem, because then they are not actually, actually we will have, this logic is not correct, because we will not have considered flippedness, but we can also do just this, like, we can just skip flipped edges altogether. So because, like, we will always find a corner that is, like, we can always, flipped or not, it will always have, like, 2 edges that are unique, and we can always rotate it so that it's the upper left corner. Flipped. Is it flip? Nope. It's flipped. And edges is a... Wait, so E... and do this, of course. e.flipped. I'm afraid I will not get done today. This is annoying. Dissatisfying. Okay, now this actually works. Now we have two corners. We also know that they have not been flipped. That they are just yeah. And again, we want to figure out which of those like their rotation should differ by at most 1, either by -1 or by +1. So we can say switch ue0.rot minus ue1.rot, case 1, case -1, default, return errors.new, unique edges are not adjacent, or corner edges or whatever. If it's 1, this means ua0.rot is one bigger than ue1.rot, meaning the ue0 will be the first edge we encounter in clockwise direction. Oh, there could also be 3. Man, I don't like this. Okay, same code as before. Case ue0.rot +1 mod 4 equals ue1.rot. And the same with the two reversed. So if this is the case, ue1 will be the latter one. So ue1 plus 1 modulo 4 equals ue1, ue0 plus 1 equals ue1 means like, for example, ue0 can be 0 and ue1 is 1, so ue0 is the first one, is in clockwise direction, the first one we encounter. This could also be like 3, and this could be 0, but then still in clockwise direction it would be the left one that we are interested in. So if we actually undo the rotation of ue0, we should end with the tile that we want. So var corner tile. So corner equals rotate tile, and we will rotate the tile denoted by ue0.edge. They will They will both have the same tile, and the rotation number will be 4 minus ue0.rot, right? Like if, and like we can also do mod 4 just so we end up with 0. So if the ue0.rot, oh no, we want this actually to be at the left edge. Yeah, so we want the ue0 to be the left and ue1 to be the upper edge, right? So we need to rotate it this many times. So basically, if ue1 is like 2, so we have rotated 180 degrees, we want to undo that. So we want to rotate 360 minus 180 degrees, so 180 degrees. If it's like 1, we want to rotate thrice. Yeah, for example, if it's 1, it's the right edge. And then we want to rotate like once and 3 times, and like it starts like this, and it starts, I can't do the thing. It starts like so the corner starts like this, and then we want to rotate it to first be this, and then another time like this is UE1 because UE0 is the like left of the two corners. So if this is 1, I want to rotate it like once, and then rotating it again will lead to like this result. Then rotating it again will lead to this result, which is basically where we want to add right. This is how we want to rotate the corner. So if UE1 is 1, we want to rotate it thrice to get to the position that we want. I hope this is. I assume this is unclear, but unfortunately, if I actually want to get something done, today, I need to power through. This actually doesn't matter. But anyway, and this is of course the opposite. And now corner should be rotated correctly and be the correct tile. Right. Let's hope. Here's hoping. So next thing. Now we need to do the same thing again. So var ordered is a slice of tile starting with the corner for len ordered less than len tiles. First if len ordered mod 12 is not 0, we need to look at the right tile, at the right edge of the last tile. Last, the edge will be 1 and it shouldn't be flipped. And we will look that up in edges. So this will be the edge that should be put next in the list. And now we need to look up the tile and revert the flippedness if it was flipped. So first let's revert the. First let's look up the tile. So this is the tile we are interested in. We actually need to look at, we have 2 tiles, so we again need to look at both of them, because these are 2 edges. If e dot tile equals last dot tile, last dot index, continue. Otherwise, t equals ts e dot tile. Let's just, for now, let's not be paranoid and let's just, if t dot index, is index by the way? Yeah, it's correct. Equals 0, return errors dot new, could not find matching tile. Let's be paranoid. Otherwise, tile should be the tile we are interested in. We are actually interested in the edge, not the tile. And if next edge dot tile or whatever. Okay, so here now again t will be ts next edge dot tile. Then we need to undo the rotation. T equals rotate tile t by, and again we will use 4 minus next edge dot rot mod 4. Nope, this will put the edge at the top. Oh, we actually need to undo first, because then we might have to flip and then we have to rotate it into the right thing to actually do what we want. Yeah, I think we have to do this. Because flipped is always to the unrotated state. So let's first rotate it. Then if next edge dot flipped t equals flip tile t, and now we have to rotate it to the position that we want, which is that the edge that we just found should now be edge number 3, should now be the left edge. So rotate it 3 times to get it to the right position, and then we should say or dot equals append or dot this tile and continue. Cool, maybe, I don't know. If this is not the case, if this is not if we don't have like this is if we are just looking at an inner tile, or like not the first tile in a row. If it's mod 12 0, we are looking at the first tile in a row, and now we need to look at the last row. So the last row, this time the last row will be ordered, then ordered minus 12. So now the tile we need to look at is the tile that is the first in the last row. The edge we need to look at is the bottom edge, but it needs to be flipped. So s equals edges extract edge of last edge 2, not flipped, because we just want the rotation, not the flip. Like this flip parameter to extract edge now doesn't make any sense because we never do that. Okay, var next edge. The rest of the code, I think the rest of the code is basically the same, more or less. With some minor modifications. So next edge either tile equals last dot index. I think this is correct. Then we are looking at the tile, then we rotate it back. This is also the same. Then we flip it, but now, yeah, now we don't need this rotation because the edge we are joining is already the upper edge, so we don't need this rotation. Isn't it called ordered? Yes, it is. Okay, so now ordered, at this point ordered should technically be correct. So let's copy ordered over the tiles and return that no error has occurred. Ordered is not defined, now it is defined. Let's run it on the test input first and see what happens. Oh, we should of course also we need to actually use the n after all. N equals len this is annoying, but whatever. Calculating a square root of an integer is not nice. But the example only has 3 and doesn't have 12, so whatever. So this is also an n. Do we mention 12 anywhere? No. Okay, let's see what this does. If this doesn't work, I'm afraid I will have to just be done with it, because again, I have to do a hard cut off at 7 p.m. For range tiles, for all tiles, if I mod n equals 0, fm.println, and let's do another fm.println. Let's do 2. No, we just want one empty row. Oh, actually printing them is gonna be annoying as frick. For I 0, I less than n, I plus plus, this will be the row of tiles we currently print. This will be the column of tiles we currently print. Tile I times n weight column. So I will be the row, j will be the column, plus j dot tile film dot print air film dot print space. Then we have printed a row. This is not what we want. Film.print tiles, first the row of tiles, ei times n plus j. This is the tile, and now we need to do it for all rows. I'm starting to get dizzy in printing this frickin' set of tiles. Okay, so what do we want to print? Actually, we want to print we just want, because we just want to print the first row of this tile, or the nth row of this tile. 0 r less than tiles 0 dot tile len. I'm rushing things, and then dot print a space, and then do that for all the rows, and then dot print a new line, and then dot print another new line once we done all the things. So let's see what this does if we don't reorder the tiles first. Undefined TS, that's fine. Test import. Panic! Only 10 minutes left. This does not look like the grid we want to output, right? Tiles I times n plus j. J is the column tile, I is the row tile. Yeah, first this, then this, then this, then this, then this. R should be the row. Again, so is this first row, first tile? No, it's not. Not even close. It's not the first row of any of the tiles. This is discouraging. Oh, this is, oh god. Yeah, I don't think I will finish today, like, because the probability that this will just run on the first try is basically 0, and I don't have the time to debug anything. Again, test input. Let's just copy the test input so we don't always have to. Why does this print such broken garbage? Yeah, thank you, regular expression search. Oh, this is actually the first row of the first tile. So this is almost encouraging. Is the next also the next row of the next tile? This would be, so this one is this thing. That's wrong. Oh yeah, this is maybe like this. Yeah, this looks almost good. How much tiles do we have? 9. But like, this is the first right, and this is the second right. Wait, which one is this? This is the second. 4, 4, 4, dot, dot, dot. This is the third. This is the fourth tile, and then it just stops for some reason. Okay, encouraging. I less than. Why is this? Freaking. Better. Oh no, I don't want to. I'm. Just to be clear, no, we only get 8 tiles. Why do we only get 8 tiles? There are 9 tiles. Ha ha ha! Remember that I said I will be bitten by that? That I assumed there's a trailing new line. Okay, so now at least we know that the tile printing logic somewhat works. So let's see what this reorder tiles does on the test case. If this now doesn't work, we are screwed. Or I am screwed, rather. 24 edges are unique. That's, I think, fine. Because this should be 4 times n, 8 times n. Nope. Doesn't do it. Actually, it breaks completely. Every tile is the same tile. This is garbage. This is trash. This is trash. Extreme trash. Trash. Complete trash. Why is this trash? It always prints the same tile. It does find... Is the corner it finds correct? Nope, it doesn't even find the correct. Does it find? Oh, is the corner correct? Is one question because we don't know, because there are the corner it may find is not unique. So the corner we find is a dot hash 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 hash. Is there somewhere a dot for 5 hashes? Can't find it in any of the corners. Dot hash. No. This isn't it. This isn't it. Dot hash hash hash. This isn't it. Dot hash something. No, it doesn't even find the correct corner. Oh, it might be flipped. Technically speaking, it might still be flipped. Frick. Is a dot hash, or let's say is a dot hash dot dot in one of the corners. Dot hash dot dot. Still nothing. No, I think it doesn't even find it seems to not even find the correct corner. So I don't know. Can we find this string in here? But I have to go. My DND group is waiting. Can't find this string, but this is also fine, because like, why wouldn't it? Yep, I'm screwed. This isn't working. It's not even close to working. This is discouraging AF. Yeah, what can I say except there is nothing going on here. This is just wrong. We didn't even find the correct corner, and we just appended the corner 15 times. Well, it is almost guaranteed that sometimes you will fail. And I will try not to take that as a reflection of myself. Yeah, no, I will not. I have to go. I have to leave, and I will not figure out what's wrong here. I'm sorry. I might try to figure out what's going on offline, and maybe fix it and push out a fix and tweet about it or something, and let you know. But this is like 2 hours of extremely convoluted, weird code, and it doesn't seem to do the right thing. So anyway, still thanks for watching, and yeah, I will try again tomorrow, and I now have vacation through the rest of the year, so I actually should have more time, but we'll see. Yeah, so thanks. See ya next time maybe. Bye.